All right. Good evening, everybody. Yes, we give thanks for once again we are here to learn. We thank you, Lord, for this opportunity. We pray for wisdom and understanding. In Jesus' name, amen. So, in this class, we want to look at the probability distribution that we can apply given a particular data type. Or should I say, yes, data type. Now, the first common probability distribution we have is binomial distribution. The binomial distribution is a discrete distribution that represents the number of successes in n independent trials, each of which has success probability. All of the infinite different values of n and p define a whole family of different binomial distributions. The outcome of a random variable that follows a binomial distribution is a whole number from 0 to n. That is n plus 1 different possible values. If n equals to 1, a special name, Bernoulli distribution may be used. If random variable x follows a Bernoulli distribution with parameter p, then starting that the probability of x equals to 1 equals to p, and x equals to 0 equals to 1 minus p, fully defines the distribution of x. If we let x represent the random outcome of a binomial random variable with parameters n and p, and let x represent any particular outcome as a whole number from 0 to n, then the probability mass function of a binomial distribution tells us the probability that the outcome will be x. Probability of capital X equals to small letter x equals to function of x, then the factorial of n divided by n minus x factorial and x factorial, all in brackets, then multiplied by probability p of x, p raised to the power x, and 1 minus p raised to the power of n minus x. All right. Now, of all the English spoken there, what we deduce here is that Bernoulli distribution is when the number of events equals to 1. Then we have it under, when it's more than 1, we call it a binomial distribution. For example, you may want to find the likelihood or probability that a student involved in violent conduct is reprimanded. Remember yesterday, we talked about doing a research, conducting a research to know, it has to do violent, okay. Since we skipped that, let's just read this. So if you conduct a research to understand violent occurrences, So you now have the probability that a student who was involved in a violent conduct is being reprimanded. For every event, the probability of success as a student being caught if it's involved in violent conduct, let's say it follows a Bernoulli distribution, then for several events, we can predict the probability of successes. Bernoulli distribution is an example of a probability mass function where X is expected success given n events, while P is the probability of X occurrence given past events. So in a situation where a student is being reprimanded, we can call that a success. And then we can predict, given an event, let's say we have 20 events, n equals to 20. After having the probability, we can now say, what is the probability of having successes, that is X, number of X, given 20 events. Okay, say we have 20 events and we are looking for 20 successes. What is the probability of having 20 successes in 20 events? Or what's the probability of having at least 19 successes in 20 events of a 20 violent events, as in reprimanding students involved in the violent acts? So whenever we have such situation, we know that the analysis, the particular probability function we likely are going to use is the binomial distribution. In a situation whereby we have to look in a discrete kind of data, we need more than one success. Like we have several successes, we use a multinomial distribution. Like I gave an example here, semester exams can be predicted using the multinomial distribution. Given previous successes in that exams, we can calculate the probability of someone passing a particular course. So out of, let's say, 6 to 10 courses per time, so we can say what is the probability of having all of them as success. So passing all your courses in that semester. So in such a case, we might use a multinomial. We might say, what is the probability of having certain attributes? Like example in this text has to do with picking candies, red, blue, and green candies from a sack, a bag. So they gave, this is what has been previously recorded as successes. So imagine more bags of candies are brought. We can actually calculate the probability of having certain number of candies, having several successes. So in such a case, when you need to calculate more than one success, you use the multinomial distribution. Then there is a Poisson distribution. Poisson distribution actually deals with successes only, doesn't deal with let's say, does not deal with probability of success given several events or given number of events. So the event itself in Poisson distribution are successes. So Poisson calculates the number of success you can have at a particular time, given that no same success can occur at the same time. So this event is only interested in success, as this distribution is only interested in success as the event. So the mean and the variance are equal. That is, mean equals to variance. So in Poisson distribution, the mean is equals to the variance. So you do not have a variance from the mean. So you can see the formula of the Poisson distribution. Where a typical example of Poisson distribution is waiting time. Example, you go to a fuel station. Even if there are several pumps, each of the pump follows a Poisson distribution because the attendant can only attend to one person at a time. The attendant in the other pump can only attend to one person at a time. The same thing, Poisson distribution follows withdrawal from a bank account. So no two transactions, no two success can occur at the same time. So you can only do it once. So in such a situation, you apply Poisson distribution. So if you are asked to, if you are given a set of data of successes over time, so now the successes becomes an event, and you have to calculate the probability. You have to know what probability distribution you have to use. Then you know that it is a Poisson distribution because Poisson deals with successes over time, where the mean equals to the variance. So you have to, in Poisson distribution, you calculate the mean and then you calculate the variance. The mean is the waiting time. So even when you are working with a computer, I think the computer processor follows a Poisson distribution too, because all the operations cannot run, how do you call it? They don't enter the processor at the same time. One has to go into the processor and leave before the next one enters. Then we now have the Gaussian normal distribution. So the other three we mentioned, the binomial, multinomial, and Poisson, are all probability mass functions. Then the Gaussian distribution is a probability density function, where several events, given that they are continuous events, they follow a normal distribution, and then they have a bell shape. The reason that they follow a normal distribution as seen in this graph is that the event has occurred over and over again, such that after, if you draw a sample in a population, and the more sample you draw, the more you are close to the characteristics of the population such that the mean between your samples, the average mean, or let's say your sample, the cumulative of your sample mean now tends to be as the population mean, such that the difference between your sample means and the population mean tends to 0. And in such a case, the variance itself will be equals to 1, because your mean all over the calculation of variance, which has to do with the mean over the number of population. So it will now become 1, as in sigma squared becomes an identity, such that the variance of the sample is similar, is identical to the variance of the population. So by that, we now result in normal distribution. If you are working with a very large population, this might likely be difficult. But if you are working with a population that is large, but reasonably large, not that very large, like the entire population of Nigeria, you will definitely get close to a normal distribution, because the more sample you are collecting to run your experiments, the more you are close to the population, getting the characteristics of the population. And by that, you are going to get this normal distribution. Then there are characteristics of the normal distribution that the mean tends to 0 and the variance becomes identical. That is the difference. There is no difference. So we now come to the t distribution. Now, it is easier to work with a t distribution than to work with a normal distribution. The reason being that in the t distribution, it has a bell shape, but its tail is not as flat as this one in the normal distribution. There is more space in the tail of the distribution than there is in the normal distribution. The idea of the t distribution is that once you obtain several data, a sample, you can decide to test using the t distribution to test if you are close to the main population, or you can compare 2 different samples or 2 different populations using the t distribution. That is the beauty of the t distribution. That is the beauty. I made a comment here. I think I didn't save it. I didn't save it, so I'll just explain. An example of a t distribution is this. In that comment I made, which I probably did not save, is that a unified exam like JAM or WAEC, which is taken across all states in Nigeria, you might say you want to test if you want to check if a particular sample that you got, like in Akwa Ibom State, you sample some schools, want to see if actually the sample you got is similar with the total population. Let's say the number of people that had A's in WAEC or the general results in WAEC. So you can compare your sample. How close is it with the entire population? In such a case, comparing a particular sample, like samples you got from a state in Akwa Ibom State, in Akwa Ibom, you can compare it with the one that is gotten with the total of all that was gotten across the nation. So in such a case, you use T distribution. So if you got samples up to 20 or so, given the number of schools that wrote WAEC with all JAM in Akwa Ibom State, you will see how close they are. So you compare the two, and by that you are going to use the T distribution. Another way of using the T distribution is that if you are given data from, you draft two samples from a population, you want to see how each of the samples are close, or they are they vary, how they vary, you use the T distribution. So, then while reading a lot of analysis, by this you should be able to understand when you see a T distribution in an analysis, you know that they are trying to compare two different samples or two different populations, either a population compared to either a sample compared to the main population, or a population compared to a population, or a sample compared to a sample. So whenever you see chi-square distribution in any analysis, chi-square only deals with categorical data. So if you are working with categorical data, you are definitely going to use chi-square. Example, after we had gotten the passes of the unified exams, we might say, let's categorize. Let's know the number of people that had A and the number of people that had B's in WAEC. So in such a case, we have turned the data into categorical data. And by turning the data into categorical data, we now use chi-square. So whenever you see chi-square in an analysis, it is because the data had been categorized, how do you call it? Categoricalized. So anyhow, just understand that the data, the variables have been placed into different categories. So that is how you read that. So the idea of chi-square is to tell you if there's a difference after splitting it into categories, if there's actually a difference between this population and this population, or this sample and the main population, or this sample and another sample. Like we were talking of people that scored A and B's, which are the distinctions in WAEC. You might say people that scored A and B's in Akwa Ibom can be compared, like samples that we got in Akwa Ibom can be compared to the general population of people that scored A and B. We can compare sample of people that scored A and B with another sample of people that scored A and B. We can also compare sample of people that scored A and B in a population from Akwa Ibom with sample of people that scored A and B from a population in Abuja. So once you see chi-square, know that the data have been categorized. So the next one we have is the F distribution. The F distribution is a continuation of the chi-square. The difference is that in F distribution, you deal with the variance. So the variances of the population, you don't deal with the population itself. Also, I forgot to make this in T distribution that we explained. In T distribution, it is always assumed that the variance is not known. That is why I say it is preferable to use the T distribution than to use the normal distribution, because in normal distribution, we do not know the exact population. So T distribution, with T distribution, you do not assume that variance is identical with the other one. So you just do the test. So it is a better test than normal. So once you are successful with the T distribution, it is the result of the T distribution that will tell you whether that data is close to a normal distribution. Tells you how close that data is to a normal distribution. So having said that, we come to the end of that class. Now our next class, next weekend, we are going to exploratory data analysis, where we are going to start reading the kind of data graph and the rest of them. So hopefully, I hope we are progressing. Thank you for coming around. I hope you understood at least to the points that you were able to get to.
Yes, I understood the T distribution, chi-square, F distribution. Yes, very well.
So all population.
Please, I have a question.
Please.
Can I go on?
Yes, continue.
Okay. With the question, or when we were given a data, will it state which of the distribution to be used, or we are the one to discern which the distribution to be used?
Once you see is a group of data, will not be given, but once you see a data, you should be able to understand what kind of distribution to use. If the data is discrete, like I explained, if the data is discrete data, you see students and their ages, their discrete data, they are given in discrete form. You know that most things you are going to look at is the probability mass function. Look at the question that is needed. What does the person want to find out from the data? It is from there you'll be able to do an analysis. So if the person wants to know, like, what is the probability of having somebody who is 16 years in SS3? So you now know 16 years is a success now. Understand?
Yes.
So now, the probability of having 16 years over those years will now be number of 16 years all over the total number of
Number of
Then from there, the probability of success now has been given. You have now solved that one. Now, the person might say that he wants to admit more students next year. So is it possible for him to have more 16 years old in that class than in previous years? Are you getting it? So
yes,
all depends on what the person is asking. So from that data, the person now wants to know several successes, more than one success. You know that what you are doing is a multinomial distribution. You understand?
okay.
So the how do you call it? The computer itself, once you just do the analysis, in the case of SPSS, even though we may likely not use it, will bring out most of these things. But the problem people have is in the interpretation, because it might give you a lot of calculations, but if you do not know, you do not know. But by this, you'll be able to explain to the person what the analysis is saying. I hope you understand now.
Yes, please.
So these are discrete data.
Okay.
Then in a situation whereby the person is talking about successes only, okay, but people keep, he has 20 people that pass exams, only successes only. You know very well that in the case of successes only, over time, that using the Poisson distribution, because the data set does not tell you to find the probability of having a particular success. The data set is already telling you that these are already successes.
Yes.
This person has been withdrawing from this account over time. This is the number of people at the ATM point. Understand? And this is how this is the time that they are spending to withdraw. All of them are success, because anybody going to the ATM wants to withdraw. Once the person uses not withdraw per se, wants to use the ATM. But the person using the ATM and leaving is a success. Person going to the fuel station and leaving is a success. Somebody using the computer, so long as the computer is on, it's a success. So when you see something that has to do with a user all over time, you know that you are dealing with a Poisson distribution. Are you getting it? So you know that the variance and the mean are the same, because all of them are successes. You are not to find, they don't have categories. It's just user time, arrival time, going time, or how do you call it? Arrival time, service time, arrival time, service time, arrival time, service time. Even in the bank, Poisson distribution is used, because the teller have to attend to this person before. As that person leaves, then that service is a success. If that person does not leave, that service is not a success. I hope you understand.
Yes, please.
So the kind of data you are given tells you the kind of analysis you are going to do.
Analysis I will apply.
So whenever you see an entire population, definitely the mean will be turned into 0 and the variance will be identical. That's right. But
Yes.
it's not proper to like working with an entire population. So that is why it is preferable to use the T, because you are drawing samples from the population. My battery is low. I think we can end this class here.
Okay.
Return
I think I
data.
got now. It's because you've explained some of the analysis before I joined. That's why. But now I got it.
Yes. So in the T distribution, as you are drawing samples, you can either compare sample with a sample or compare sample with the main population that you already got, or you compare a population and another population. So once you see such a situation in the, when you say t-test in an analysis, you know that there are two comparison of data.
Yes.
So while chi distribution, let me use my phone, let me continue. While chi distribution, in chi distribution is mainly categorical data. You understand now?
Yes, please.
Yes. Only categorical data works with chi distribution. So once you see a chi test, know that they have turned that data and grouped them into categories. If they were talking about numbers now, they have now grouped them into categories. They might be saying male, female, black, white, understand? Class 1, class 2,
Yes.
or rank. They might group them into rank. They might group them either ordinal or nominal, like we explained, categorical data. So once you see Kai's test, understand that the data has been put into different categories. So you are no longer looking at the variables now, as they were before. You are now looking at the variables have now changed into a new variable that deals with categories. Okay. It might be that same population that you were doing analysis in, understand? Like in the case we're talking about students passing WAEC. So now they have switched from number of students that passes into number of students that scored A or B or C or D. Understand? So you now interpret the data differently from you when you started running your analysis. So you now know once you see chi-squared that the data has been turned into categories. So the next one is F distribution. F distribution is just a chi-square analysis, but it compares different variances of different population of chi-square distribution. Like the variance of a population, if you took samples in different schools, it compares their variances. So that is what F distribution does. So I hope you understand.
Very well, huh? Very well.
So once you see an analysis, understanding all these things, you'll be able to read and interpret to the person. This is what this one means. This is what it means. And once you see a data and you hear the question, you should be able to tell you what kind of analysis you have. As we go on, we get more understanding.
Yes.
Thank you. Good night.
Thank you very much.
You're welcome.
Thanks for your time.
So we give thanks to God once again. We pray that whatever we have learned today, we to understand it better in future. These are prayers in Jesus' name. Amen.
Amen. Good night.
Amen.